Anyway, let me do a brief introduction. So it's my great honor to have Elisabeth Andre talking to us now. She's from the University of Augsburg in Germany, and she's an expert on using multimodal communication and using AI to understand human speech and multimodal signals. So she's going to talk to us today about how to interact with agents and using mixed reality and AR and VR. So I'll turn the time to you, Elisabeth, and we'll have your presentation, and then we will have time for questions at the end of it. So thank you very much. And I'll be looking at them in the chat. So if anybody has any questions, they can type in the chat, or we can ask it face to face at the end. Okay, so please
Yeah,
take it, Elizabeth. That's great.
thank you very much for the introduction and the opportunity to give a talk. That's a great honor for me. And today I will show how AI-based multimodal communication can enhance both human-human and human-machine communication across diverse extended VR settings, both with avatars and virtual agents. And first, I would like to show some pictures that give you an impression of our work. Sorry, on socially interactive AI. And here we have the goal of developing artificial agents that mimic human communication styles. I have been working on that topic for many years, and due to advances in generative AI, I will go back to my roots again. Here you can see examples of projects we conducted, funded by the European Commission, but also two national projects. So Christina is a virtual health advisor designed to support older adults with multilingual information and guidance. So both in Germany, where we have a lot of seniors from Turkey, and in Spain, Catalonia, where we have a lot of healthcare takers from the north of Africa. Emma is a coaching assistant developed to provide psychological support through empathic dialogue. So this project is quite similar to the Trocohoa project Mark is conducting. And finally, the Navel robot, which acts as a family companion designed to engage users of all ages through social interaction. So within that national project, we built a robot, and we also developed the software. And the company Navel Robotics is now using it to in homes for older people. So this project has quite a press actually coverage. So the second brand of my research focuses on the analysis of socio-affective signals in real human interactions. In the Schwan project, we analyze how the COVID-19 pandemic has affected parenting and child development using video recordings and AI-based behavior analysis. This is quite challenging because, the babies are quite small. So tools such as open pose don't work. And so we had to find different solutions. And also, as you can see here, the mother is usually covering the child, and there are a lot of unpredicted events. Serap AI is a project that we conduct together with colleagues from psychotherapy. And in short, the psychotherapists want to know why psychotherapy sometimes works for people and sometimes not. And their hypothesis is that it depends on the emotions of the therapist and the patient. And here we use multimodal data, including facial expressions, voice, and posture, to investigate how emotions evolve throughout the session and also the relationship between the therapist and the patient. And finally, Codill focuses on simulated medical consultations, and here we study how AI-generated feedback can support communication training for medical professionals. And all these projects rely on AI to help us uncover patterns and dynamics in human behavior. But at the same time, these techniques provide a good foundation for building agents that can interpret and respond to human behavior in socially and emotionally appropriate ways. So here I would like to give an overview of my talk. So I will first discuss how extended virtual reality can connect people across distances using collaborative activities like virtual jamming. So actually this project has been conducted with Mark and Kunal from his team. Then I will talk about group work in virtual realities. So I will discuss virtual classrooms where teamwork is crucial. And here I focus on eye blinks as indicators of group interaction activity. I will then explore how empathy can be fostered by experiencing the perspective of others through an avatar. And after that, I will shift to applications involving autonomous agents, showcasing their role in social coaching through a virtual reality role play. And before I conclude, I will present some tools we developed at my lab to support the development of socially interactive agents, and we are happy to share these tools. They are all open source. So first, I would like to talk about how to connect people, in particular musicians, across distances. As I said, this was inspired by the collaboration with Mark Billinghurst. And so as you all remember, the COVID pandemic isolated musicians, making in-person jamming sessions virtually impossible. And at that time, we had a PhD student from Mark's lab, and he couldn't go back to New Zealand due to the pandemics from India. So he spent some time in Augsburg, which was also not ideal because so Kunal could not come to the university. And so we got the idea to help musicians actually to get connected. And existing remote solutions primarily focus on audio-only experiences, which lack the sense of connection and co-presence that in-person collaboration provides. And we saw that by leveraging mixed reality systems, musicians could not only hear each other, but also share a virtual space where they can interact and perform together. So even though this idea is very obvious and promising, its potential has been underexplored due to latency-related technical problems. So we did not aim to solve latency issues, but we bypassed this challenge by using analog audio hardware to locally connect to laboratory rooms. So I will show you how that worked. So basically, we stream point clouds of jamming partners that are in different rooms to each other. So here you can see the jamming session from the perspective of a musician. So in the foreground on the left, his own guitar, and on the right, the musical partner appears as a 3D point cloud. And here you can see the jamming session from the perspective of both musicians. So as I said, we stream point clouds of jamming partners who are located in separate rooms in real time to enable shared musical experiences. So in our current work to improve the quality, we are enhancing these point clouds using style conversion models to improve the overall realism of the interaction. So I will show you a video of the former system.
In a laboratory study, we connected musicians that were jamming with each other in separate rooms with head-mounted displays. With these headsets, musicians could experience each other's 3D point clouds while jamming. Let's see and hear an example jam.
Okay, A-Moll, F, C, G.
Okay, just to give you an idea. And we also conducted a lab study with 24 participants. So we invited a couple of people with their instruments. So these pairs improvised with their chosen instruments. You can see there was quite a variety. And we compared the psychological effects of jamming in audio only and mixed reality conditions. And here just some results. So participants did not experience a greater sense of flow in the mixed reality condition compared to the audio condition. This may be explained by the increased physical demands in mixed realities due to intense improvisation moments. And it was disturbing that the musicians had to wear head-mounted displays while simultaneously amplifying their musical performances. But we were happy to see that there was a much greater sense for a social presence. We also used shimmer sensors to record physiological signals such as beats per minute. And the analysis was quite promising, so it revealed that the flow state is associated with distinctive physiological patterns. Real-time assessment of the assessment of real-time assessment of flow is possible. So there is the potential to adapt the scenario. And we also conducted a qualitative feedback. And so here you can see a summary of the statements of the jamming partners. Overall, the mixed reality setup appears to improve communication between the jamming partners. So the remaining challenges are actually to make sure that people see the instruments in a better manner to coordinate their hand movements. So improve communication on the positive side and trouble seeing instruments as a challenge. And so overall, this was a positive experience. Co-presence was higher in mixed reality. Physical flow assessment in real time is feasible. And also we observed a positive effect increased after jamming. And there are some remaining technical issues which we tried to solve in the meantime. So in terms of hardware, we made a major leap forward. So the biggest upgrade was replacing the HTC Vive with the Vario headset. And the new device offers a much higher resolution and a significantly lower latency, which has greatly improved the visual quality of our environment. And Vario also features a depth occlusion, creating a more realistic and immersive experience. And the other improvement is that we employed a second Kinect camera in combination with a cloud alignment algorithm. And as you can see here, the visual quality has improved. So here you can see what we had before. And now you can see the improvement. So the quality, the resolution has improved, but we still need to solve some issues with the visualization of the head of the people, which is challenging to the head-mounted displays. So the next topic I would like to talk about is group work in virtual reality. And this work has been conducted in a national project with Mark Latoszek from the University of Würzburg and people from the pedagogical field from Würzburg and the Technical University of Munich. So this project so this work was conducted in the We Learn More project that aims to record and analyze cognitive and social affective behavioral signals to explore emotional regulation mechanisms that modulate learning behavior in virtual reality. So this was very important to our partners from the pedagogical field. And the original We Learn project applied situated learning, that is learning about a virtual reality while in a virtual reality. So when you see the scenario, you might wonder, why do you use a virtual reality to teach people who are actually already in the same room? But here the main idea is actually to expose pre-service teachers to virtual reality and to enable them to discuss virtual reality or the potential of virtual reality for teaching. So virtual reality offers interactive learning in scenarios that are otherwise costly or unsafe. So actually you could also move the classroom to a different environment. And so in the prior project, so we joined in the second phase because they wanted our technology to analyze social and effective signals. So there was some evidence that virtual reality is very promising for this kind of application. The participants felt a stronger sense of community due to this collaboration, but we wanted to analyze this in a more systematic manner to use sensing technology and machine learning. So here you can see what the scenario looked like. So we have a classroom and people are interacting in dyads and triads. This was a long data collection going over 1 year. And people were sitting together in couples or in triads. And so they were asked to have a 10 minutes conversation about a seminar topic per group. This was only one part of this lecture. And we recorded all this data. So here you can see the playback of the interaction recorded with additional features such as the ray for indicating gaze direction and a micro symbol for indicating who is speaking. So as I said, we are in particular interested in the blinks of social interaction. So eye blinks are not only physiological for humidifying the eye. A large percentage of blinks is actually associated with communicative aspects. So blink duration impacts the communicative behaviors. For example, there are studies who found out that participants unconsciously responded with shorter answers to interlocutors, longer blinks. And blink synchronization is also a very interesting indicator. So looking at the blink sync, you can predict interest level, so a higher amount of synchrony of blinks between people indicates a higher interest in the conversation. And blinks are also, or synchrony of blinks are also good indicators for problem solving performance. Here, higher synchrony shows better performance. And finally, synchrony of blinks can also indicate effective social communication. So surprisingly, even though there's evidence from social interactions, so blinks have been studied little in social interactions in virtual environments. There are some studies, I listed some of them here. So as you know, virtual environments can have a visual fatigue, leading to an increased blink rate. And a higher blink rate was recorded for participants exploring an environment in virtual reality compared to a 2D screen. And also people compared blink rates of people playing Flappy Bird in virtual reality compared to a 3D screen. So here also in the virtual reality there was a higher blink rate. And additionally, the blinks information within virtual learning environments may indicate engagement, task performance, and interest level. And so we thought it would be really valuable to investigate blink rates. So as I said, we collected a large amount of data over a period of 1 year with pre-service teachers who had to do the course anyway. And so we found some interesting results. So we looked at how people blink when talking in virtual reality, either in pairs or groups of 3. And we found that blink rates in dyads were similar to face-to-face conversations, but lower in triads, probably because people speak less and listen more in larger groups. So similar results were obtained for real scenarios when you had a presenter. And blink synchrony, that is how often people blink at the same time, was slightly higher in diets, but the difference wasn't significant. And this might relate to overall blink rate. And we are looking at this in more detail with a colleague currently visiting from the University of British Columbia, Christina Conati. And the timing of synchronized blinks was similar in both group sizes and matched also patterns seen in real-world interactions. And all these results suggest that blink behavior in virtual reality could be a useful signal for understanding communication quality, engagement, and collaboration. So we organized an international challenge on group discussions in triads and in groups with 4 people in the real world. This is going on at ACM Multimedia over the past years. And since we got the data from the real scenarios and the data from the virtual reality scenarios, we have the chance to perform a systematic comparison. So next, I would like to talk about perspective taking in a virtual reality. So this work was conducted in a project funded by the Volkswagen VW Foundation. And it's a large international project with partners in India, China, South America, several countries in Europe. And here we wanted to investigate how AI-based decision-making is done in different countries for the allocation of public services. And we want to understand better culturally influenced values and their resulting implications, and also to find out what would be a desirable application of AI-based decision-making for allocation of public services. And usually the AI is trained on data sets from the real world. And as you can imagine, bias and social injustices are often reproduced. For example, the bias might be more felt by affected and underprivileged persons. So when you look at data sets for assessing the creditworthiness of people, so usually younger people have a disadvantage. And we conducted studies in different countries. And because in Estland, in Europe, the digitalization is very much advanced, we went to Estland. And we conducted studies with people in a job center. And we found that actually we probably should provide some training to the people to help them to build empathy among stakeholders. And Ruben Schlagowski, who was involved in that project, thought, okay, why not try virtual reality for empathy building? And here you can see the scenario. So a participant embodies a persona representing a differently privileged demographic group via virtual reality, full body tracking. And to get acquainted to the scenario, they were facing a mirrored elevator before getting confronted with the biased AI system. And we conducted a study to compare 2 forms of role playing in a credit scoring scenario, so one based on mental embodiment and the other on virtual embodiment. And in the mental embodiment condition, participants were given profiles of 4 personas in a printed form. And the participants role-played these profiles while being assessed by a Wizard of Oz credit scoring AI in our lab environment. And in the virtual embodiment condition, participants embodied the same personas in virtual reality. And using motion capture, they took on the appearance and movements of virtual avatars. And they received their persona profiles digitally and entered a virtual replica of the lab environment. So to make the 2 conditions comparable. And there was also a digital version of the AI system in the virtual reality. So this was to enable a fair comparison. And our goal was to investigate how people perceive and emotionally react to unfair AI decisions, particularly when those decisions are based on socially sensitive factors like gender or age. And so our hope was that participants won't just understand the injustice intellectually, but actually feel affected, similar to somebody who truly belongs to such a group. So we also wanted to investigate the effective impact on it. So here our main findings. We observed that a virtual reality-based embodiment can have a measurable psychological impact. So we observed that empathy levels increased when participants embodied underprivileged personas, and they felt more emotionally connected to the experience. And second, the AI bias was stronger in the virtual reality than in the non-immersive settings, suggesting that immersive perspective taking can intensify awareness of algorithmic injustice. And interestingly, this effect was reduced when participants embodied privileged characters. In such cases, the same unfair decisions were perceived as less biased. So this is, I think, quite interesting. So up to this point, I have focused on avatars controlled by humans. So now I would like to shift to autonomous agents, so virtual characters whose behavior is driven by AI. And as an application scenario, I would like to focus on social coaching, where role-playing involves virtual agents that actively engage with a human in an interactive dialogue. So as you can see here, the user takes part in a gamified job interview simulation led by a virtual recruiter. And so the purpose of this scenario is to help young people to improve social skills, in particular to make them less nervous for a real job interview. And this was conducted first in a European project and continued in a national project with several companies we collaborate with. So we give people physical game cards, so to provide them with hints on how to behave. So for example, the card on the right tells the user how to make a friendly impression when greeting the interviewer. This made the whole experience more structured. And during the game, sensors record and analyze the user's behavior in real time, as you can see here. And we focused on the following social signals: speech rate, body movement energy, and body movement openness. And to make it like a game, or to introduce gamification elements, a scoring system tracks the quality of the user's behavior and provides an evaluation. And what is important to know is that when AI or behavior analysis is used to assess people, it does not suffice to tell the people, okay, your performance was bad, you would never get a job. It's also important to provide people with an explanation. And you can see here the first interface we developed. So on the left-hand side, you have a user who appears very engaged. So he has an open body posture. He leans forward towards the interlocutor. And on the right-hand side, you have the opposite. So the guy is leaning backwards, crossing arms, and looking away from the interlocutor. So crossing arms is usually said not to be a positive. Crossing arms is not bad per se, but in combination with looking away, it's really not a good behavior. And we tested the system in several schools in Germany. And here are some statements from teachers and students. So the teachers thought that the students were more motivated when using the game-like environment in comparison to books, teaching them how to behave in a job interview. They said the game transports the experience of the youngsters into their own world. And the youngsters themselves said that the feedback by the system is more believable than the feedback by human assessors, which is also interesting, that the people believe the AI more than a human. And in a work on explainable AI, we focused a lot actually on counterfactual reasoning. So counterfactual reasoning basically is about what should the input look like of a system to make the AI come to a different decision. And so we applied the same idea here. So we use counterfactual explanations explaining to a user that a modified version of his or her social behavior would lead to a better behavior rating. And here we use generative adversarial networks, hypothetical examples of how the user could have acted differently. And we used an avatar to explain this to the user. So here the avatar is telling the user to give more nonverbal feedback and try to adopt a more open body postures. So we do not only provide social coaching, but also to not only provide social coaching to pupils, but also to teachers. So this is another national project where we use mixed reality training enriched with virtual agents. So here pupils behaving in a bad manner, not listening to the real teacher. And the goal is to provide an immersive and dynamic platform for simulating conflict situations in educational settings. So I will play a scenario of a pupil. So this is actually very characteristic of the situation in Germany. I experienced that myself. I don't know how it is like in Australia. So often the students play with their mobile phones. And this can make you as a teacher very nervous. So this is one of the scenarios. So you can decide yourself whether the real teacher on the left is convincing or not. So the result is actually shows that a real teacher still has to improve. So it's in German, but I think you get the idea of what it is like, and I guess so. At least maybe Mark can actually identify with the situation as a teacher.
Guten Morgen alle zusammen. Alex, würdest du bitte dein Handy weglegen?
Mache ich auf keinen Fall.
Ja, gut, so. Auf jeden Fall bei Synchronität.
Ich gehe jetzt raus.
Ja, bitte. Tschüss. Bis nächstes Mal.
So we have many of these examples, and then you can test different strategy in the hope you learn how to behave in a real setting. So finally, I would like to present you some tools we developed at my lab and which we are happy to share with. So this slide shows Melax, a real-time platform for integrating generative AI technologies into photorealistic interactive virtual agents. And the system continuously listens for voice input using voice activity detection. And we use various tools that are available, such as Whisper, Google Speech to Text, also different text-to-speech systems, including our own system, VoiceX, where users can create their own voices based, for example, on personality characteristics. And all these components are synchronized to ensure a smooth and lifelike interactions. So my student Daxita just managed to implement a good turn-taking behavior with speech overlap. He sent me a video tonight to present, but the video was not politically correct, so I will have to wait for another version, which I will make available to Mark at a later point in time. And the other tool, so we will give actually a tutorial on Melax at the Intelligent Virtual Agents Conference in Berlin this year, and we are happy to share this with you. We also developed a tool called Affect Toolbox. I think some people in Mark's group have been using it, like Aladdin, and it enables accessible real-time affect recognition for HCI applications. So we have been developed a tool called SSI, Social Signal Interpretation, which actually requires some technical expertise. And so our idea now was to develop a tool that is accessible to everybody and does not require a lot of programming skills. And I will just show you a short video which gives you the idea of what it is like. And you can see here the interface. So as a user, you click what you would like to analyze. So here the audio, video, face tracking, facial expressions, and also the emotional results, pleasure, arousal, dominance, and posture tracking is also involved. And now a short example with a user interacting.
I was so excited about my trip to Glasgow. I've been planning it for months, and the idea of exploring the city was all I could think about. But when I got to the airport, I found out my flight had been delayed by hours. Just sitting there, watching the clock, I felt pretty down. After a while, I started getting frustrated. Why didn't they give us a heads up earlier? It's like they don't even care about keeping people informed. But eventually, they announced a new boarding time.
You
And I
can see
was
how
just
pleasure
relieved it
aroused the
wasn't cancelled
dominance
altogether.
changes on the
I'll get there, just a little later than planned.
Okay, so that is a tool which is available. It's open source. And now I would like to conclude my talk. So I actually presented you 4 examples how AI and virtual reality can be used to connect people. So I started with jamming of people at different locations. Then I talked about a virtual collaboration in teaching scenarios, so virtual classrooms. Then I showed the potential of using avatars to improve empathy, so walking in other shoes. And finally, I moved to autonomous agents that are used for social role play. Overall, I think that extended virtual reality has the potential to connect people across physical distances and diverse communication abilities. So we are also working on sign language. I did not show this today. The challenge are still the reduced communication channels, which may affect the social dynamics of the conversations, but I guess this is only a matter of time. And understanding the dynamics of interaction is essential. That's why we need technologies for assessing social and effective behaviors. And so this is widely applicable, so we can have human-human interactions in real-world settings and use social signal analysis techniques. We can apply it for human-to-human interaction in extended virtual realities and for analyzing the social dynamics of human-to-agent interaction. And yeah, that's the end of my talk. Thank you very much. So if you are interested, you can also look at our tools. Yeah, now I'm looking forward to your questions.
Great. Let's thank Elisabeth. It was great. Thank you, Elisabeth. Let's open the chat channel. And does anybody have any questions here face to face? I had one question. So you gave a very nice overview of some of the tools you've been using to build your intelligent agents. What do you think are some of the developments in AI over the next few years that should help make those tools even easier or better to use? What are some new things that you think will be coming in the next few years that will help it easier to build these agents?
So I guess generative AI diffusion models might really help to make the avatars more realistic, also for the job interview training. So we applied the counterfactual approach to sport. So we had sports people, and we generated behaviors that would lead to a better performance. We currently use the skeletons because of the resource limitations, but with diffusion models we will have more realistic avatars. I guess the same for the jamming example. Diffusion models could help a lot here. And regarding conversation, I think we really need to solve the latency issues. So when you actually expose people to a large language models, you still have this strictly sequentialized behavior. So the user says something, and then the agent says something, and it's strictly sequentialized. But in reality, we have a lot of speech overlap. And to distinguish between real interruptions and interruptions that signal more that you are interested, saying, aha, this should not be interpreted as an interruption. So to have this smoothly going is a bit a challenge. And so I saw from a French company. I have to look it up. This was quite impressive. So they had simultaneous translation in real time, but you were able actually to interrupt the system. So you were talking in French, and the system was providing the English translation. But this was it was even to some extent disturbing, because the translation came at the same time as the spoken, the original language. Yeah.
Interesting. That's great. Thank you. We've got one question here. Do you want to?
I'm not for bits anymore. So.
Okay, we're going to ask a question anymore. Does anybody else in the room have a question to ask Elisabeth?
Someone's got their hands up online.
Yep. We do have one hand up online, and it's Zhuang. Do you want to Zhuang, you can unmute yourself and you can ask your question if you like.
Yes, thanks much. Hi, Elisabeth. Thanks so much for presentation. Really nice talk. I'm very interested in the toolbox you shared. It's Malux framework for building virtual agents. I'm wondering whether you and your team run any study to evaluate how well the toolbox is. Because I noticed like the input is actually the user's speech, and the output is the virtual character's facial expressions. I want to like understand how well user perceive the generated virtual character facial expressions, how natural it is.
Yeah, good question. So in that Malux toolbox, we use so it's up to the developer or the person who would like to design agents, what tools to use. For example, to use the Cereproc speech synthesis, or use our VoiceX. So a VoiceX, this is a speech synthesis tool we evaluated. So we evaluated to what extent users are happy with the voice they created. And users can have different goals. For example, does the voice actually match the visual appearance of the character? That's what we evaluated. And when we give the tutorial at IVA, so we will also test how people actually get along with the virtual agent, or with the design of the virtual agents. And what I would like to do, and what we are currently investigating, I have a student, he is doing his dissertation in Japan, and he's also involved in the development. And so we would like to find out whether people are able to create characters that reflect their own culture, or whether there is some bias in these tools that actually are tended more to reflect a specific culture. So it was somehow motivated also a bit by Togo Ahoa, where we also thought about to help young Maori man, and the character should somehow reflect the culture, or at least reflect something the user group likes. And this would be the thing we would like to evaluate first. So whether people actually get what they had in mind, or whether it was something completely different. So regarding the voices, we did not evaluate the whole tool with the characters, but we actually showed VoiceX to people who are not able to articulate themselves. So maybe the famous representative is Stephen Hawkins. And so the people actually created voices for themselves, or the relatives created voices. And then we investigated to what extent the voice was actually matching the personality of the people. Yeah. But so the MELAX was just finished, so we are ready to give the tutorial, and then the real evaluation will start. And I think focusing on culture and personality would be the most interesting thing to evaluate.
Thank you so
Great,
much.
thank you.
So may I ask another follow-up question? Because currently I noticed the general solution evolves like the speech to text and then text to speech. Do you notice, is there any useful tools that can directly map the user's speech to virtual agent speech, and the virtual agent facial expression can be directly driven by the user's speech input while not converting to the text in the middle? Because like while you convert the user speech to text, then you'll lose some of the like information like the pitch or the emotional cues in the speech. Do you know like if there is any useful tools that can directly achieve this?
So I'm not sure whether I understood your question correctly. So we have been also experimenting with cloning voices, and we run some studies with robots. So we had 3 conditions. So we had a cloned a voice cloned with the user's voice, and we had a voice that was adjusted to the agent, and a voice we used as a control actually. And also at a tutorial we gave in France, we actually recorded voices of people in different emotions, so to reflect actually the intonation for the cloned voices. So cloning voices is another option, and now the quality is actually quite good, and also it works with with a few shot learning. You don't need a tremendous amount of data to replicate your own voice.
Okay, thank you.
But
Thank
I
you.
can send you, if you send me an email, I can send you some software we actually, regarding the cloning, we not evaluated, but tested. Yeah.
Okay, thank you so much. I think I got your email. Maybe later I will just email you.
Okay, thank
I
you.
think Gunn has a question online where he says, thank you, great talk. Would the effect toolbox work for other languages and demographics as well?
Actually, the visual and the body and the face is, I would say, easy to transfer to other cultures. So basically, according to the literature, it's the situation, which. So in different cultures, people behave or show different emotions depending on the situation. So in combination with an emotional model, this should work. Regarding the speech, so we had a European project where we had speakers from Germany, the UK, Finland, Italy. So with some training, the voices could be actually adjusted to different languages and cultures. So the most difficult country was actually Finland, because they were not very emotional in general. And Italy was more difficult than we thought, because the Italians are always very expressive, even if they are sad. So if in the Germans, if they are sad, they have a very monotonous voice. But Italians always have an expressive voice. But basically, it was actually adaptable to several cultures. And also, so the Fact Toolbox is Python-based. If you should have a good Python model or any machine learning model, it's easy to integrate it if you think you have a better one for your own language. And also there's a semantic sentiment analysis is included and as well. Yeah.
Great, thank you. And I think Evan has a question as well. Do you want to unmute yourself, Evan, and ask your question?
Yes. Can you hear me?
Yes.
Yeah.
That's perfect.
Yeah.
Okay.
Yeah. Thanks, Professor Elisabeth. That was an amazing talk. And I just had a quick question about, because I have there is also a lot of physiological data was like used and analyzed in your research field. So I'm just wondering, like, when it comes to the real life scenario, like, how do you see people? Let's say if like we are trying to push this kind of research or this kind of project to a real life case, how do you see people? Do you think the people will be willing to share those kind of a raw physiological data directly to the app or to the software, or do you think it might take some time to, like, when people are kind of be more open about, like, they kind of asking my heart rate, they are asking my kind of skin conductance, and there might be need some, I'm not sure, education or need some process for people to admit that, I'd like to let the software use my physiological data. So how do you see this kind of scenario?
Yeah, it's a very good question. So in the beginning, I showed you the Therap AI project with the psychotherapist, and this is highly sensitive data. And here we do not even have access to the data, because, and I also don't want to have access to the data, because then I'm responsible of that they are safe. So we provide our software to the psychotherapist, and all the software is running locally. And this is indeed very important. Also for the job interview training. So the idea is you use the software, you use it on your local computer. And so it's up to you whether you would like to share it with a human coach to discuss how you behaved, or whether you just keep it for yourself. So so my feeling is that all these cloud service, one motivation is also the business model, but from a technical point of view and the user's point of view, it's much better to run the software locally. There's still some technical issues. So, for example, regarding the avatar we have, the local language models don't provide at the moment the same performance as the OpenAI models. But nevertheless, if you combine it with a knowledge-based approach, then this is also solved. But there is no need to share your physiological data if you don't want to do that.
Thanks.
Great, thanks so much. Does anybody else in the room here have questions for Elisabeth, or anybody online? No? Okay, well, let's thank Elisabeth again. That was great, Elisabeth. Thank you so much.
Yeah, thank you also for all the questions, and yeah.
And thank you so much for the information about the tools you're using. I'm sure some people will find that useful in the research they're doing as well. So we'll let you leave. And those of you who are online, that's the end of the lectures for today. We'll have tomorrow morning, Adelaide time, we'll have 2 lectures at 9 and 10 a.m. From Saranga, and who's going to give he's from Singapore. He's going to give us a really interesting lecture on sorry, I was reading it here, on designing intelligent human-computer interfaces to extend the limits of our peripheral and cognitive capabilities. It's at 9 o'clock in the morning, Adelaide time, and then at 10 a.m. Adelaide time, Misha Shra from University of California, she'll talk to us about designing human-AI interaction. So they'll both be really interesting talks as well. So we'll see you all tomorrow, and thanks again, Elizabeth. That was really great. We'll see you later.
Thank you, and have a nice time.
Yeah.
And
Thank you. Good morning. See you later. Bye-bye.
See you later.